Hi everyone, let's solve this problem. K closest points to origin. Given an array of points where points of I is equals to xi comma yi represents a point on x comma y plane and an integer k, return k closest points to the origin 0 comma 0. The distance between 2 points on the xy plane is the Euclidean distance, that is the x1 minus x2 whole square plus y1 minus y2 whole square overall square root. You may return the answer in any order. The answer is guaranteed to be unique. So, first of all, let's understand one thing. So, the formula x1 minus x2 or x2 minus x1, it does not matter here because we are kind of doing a square, and the second point is always going to be 0 comma 0. So, we don't really have to include it. That means I can just do x into x plus y into y. And the other thing is that, let's say for example, one distance is 8 and the other is 8, and square root of 10 comma square root of 8 should not really matter because we are just checking the distance. So I can check the closest distance by getting this value as well. I don't really need to take the square root, so we are going to skip the square root part. So we are just going to get the distance from here. So now let's see. The approach 1 to this problem would be to go through all the points. So iterate over all the points, calculate distance, and sort the array based on the distance and pick first k elements, right? So first of all, we are going to iterate over all the elements, calculate the distance. Calculating the distance would be just big O of 1, and then we are putting inside, we are sorting all the distances, so it would be n log n, and pick k elements. For every k elements we are just going to get the element based on the index, so it would be just k, and the space complexity would be n because most probably if we are using merge sort, it will take big O of n time. In case of approach 2, we are going to do the same thing, but instead of inserting into an array, we are going to insert into the heap, min heap, and pick first k elements. So I will be iterating over all the elements and I will be pushing all the elements into the heap, that is n log n, and then for k elements I am going to fetch it. It would be k log n, and the space complexity would be n because I'm using the heap of size n. So let's understand the example of this using min heap. So let me take an example here. This is the min heap and this is of size n. So I am going to insert all the elements. So first I'll calculate 3 into 3 plus 3 into 3, 9. So I'm going to insert 9 comma 3 comma 3, and then I'm going to calculate for the second point 5 into 5 plus minus 1 into minus 1. This is nothing but 25 plus 1, 26, 26 comma 5 comma minus 1, and then it is 2 minus 2 into minus 2 plus 4 into 4. It's going to be 20 minus 2 comma 4. So I have inserted all the elements into min heap. Now I'm going to fetch k elements. So my result will be an array. I will fetch the minimum. Okay, sorry, this is 9 plus 9, this would be 18, right? And so I will first fetch the minimum value. Minimum is this one, 18. So I will fetch this value and I will insert 3 comma 3, just the x comma y. I don't need to insert the distance. And then again I will fetch the minimum distance. Minimum is this 20 minus 2 comma 4. So I will be inserting minus 2 comma 4, and we are done. Now let's see a better approach than this. Approach 3, we are going to do the same thing. Iterate, calculate distance. We are now going to maintain a max heap, and we are maintaining max heap of size only k. So if size is less than k, insert the point directly, else check the top of the heap. Top of the heap will be max, right? And you will also have to check the distance. If the distance which we got is less than the max heap, only then we have to remove the element and insert the new distance. And then I am going to iterate k times and get the elements from the heap. That is going to take k log k. So basically big O of time would be n times log k plus k log k, and the space would be big O of k. So we are, instead of n log n, we are going to be getting n log k, and the space would be big O of k. So let's understand the approach. Let's take a max heap now. First element, I know the distance, so 18 comma 3 comma 3. The size is, we are maintaining size of k equal to 2. Now again I get next element, it is 26 comma 5 comma minus 1. Now I get one more element. This is nothing but 20 comma minus 2 comma 4, right? And I am going to check this. The distance is 20. The calculated distance is 20. Is it less than the max of this? Max element is 26. I'll get the entire element and I'll check the distance. If I check this, 20 is less than 26. That means we have to remove this element and insert the latest element into the heap, minus 2 comma 4, right? Let's suppose that if the distance was, instead of 20, I got, let's say, maybe 40. For suppose 40 is greater than 26. No matter, like 40 will not help us, so it makes no sense to insert into the heap, right? 26 and 18 will be the shortest distance, so I will have to return these 2 points only. But the answer we got was 20, so I am going to insert 20 comma minus 2 comma 4. Now I will iterate k times and get the result. Result would be initially 3 comma 3, or basically no, this is a max heap, so I will get the first 21. So minus 2 comma 4, this will be gone, and then I will fetch the other one, that is nothing but 3 comma 3. So this is the result, and this max heap will work because the ordering will not matter. The answer can be in any order. That is the reason max heap will work. Otherwise we will have to get the elements and then we will have to sort the array, which is not helpful. So now let's write the code for this. Max priority queue, and in this case we are going to have an array of distance comma x comma y. So we are going to tell the max heap that sort it based on the distance is nothing but inside the point we are going to insert distance comma x comma 5, so it has to pick up the point 0. Then we will declare a result array. We will iterate over all the points, and then if first we'll also calculate the distance. Distance is nothing but x into x plus y into y. We are skipping the square root as discussed. Then how are we getting x and y? We will get x comma y from point, and then if max heap dot size is less than k, just insert this element along with the distance comma x comma y. Else if calculated distance, so we are calculating the distance here, calculated distance is less than max heap dot front of 0, only then max heap dot dq, remove the previous element and insert the newly calculated one, so distance comma x comma y. And front will never be getting into null, because if the size is less than k, it will always go into if condition, so we can skip that as well. Now I will have to iterate k times, and then get the element const distance x and y from the max heap dq, and then I have to push it into result. I don't have to push the distance, so I'll just push x comma y, and then at the end we will return the result. Let's run it. Let's submit it. Okay, so as discussed, the time complexity is n log k and the space would be big O of k. I hope the solution is clear. Thank you.